couple of parameters for it. Once my AI agent is defined, what is the next step? To define the task that the agent will do. In tasks, I've imported it from crew AI import task, define the description, what should the output look like, which agent will perform this task. Finally, when all of that is done, I will define my crew from crew AI, and I will specify all the agents and tasks which are defined, and we are going to get our result. Okay, so this is it. This is under, I believe, 40 to 50 lines of code, and you have built your first AI agent. Okay. From here, the agents that we will see are going to be more application oriented. This was more towards getting you familiar with the syntax and how things are done. Now we will move on to something which is more application oriented, something that a similar version of that you can actually build in your work as well, and it will be a multi-agent system. Okay, cool. Before we move on, folks, how is it going till now? Just tell me in a sentence, for the last 1 hour, how is it going for you all? Are you all able to follow through, understand why we are doing it, how we are doing it? Are you able to like have a great time? Okay, is something? Are you all engaged enough? Are the explanations clear, and so on? Keeping up? Good. Engaged? Highly engaged? Mostly what we have seen, okay, mostly what we have seen for this particular session, this is one of those sessions where we have seen close to about 100% retention towards the end of like the 3 hours as well. Okay, so yeah, you will get more clarity, don't worry. But what I am able to sense from the chat, and folks, there are over 1,000 people on the call, please be as active on the chat as possible. Okay, if you're stuck somewhere, if you're not feeling something which is right, or you are like, why are we doing this? And I see because I have separate monitor where I'm just monitoring this chat. So if I see a bunch of different people, you don't need to write the same question multiple times. I'm reading everything that is coming here in the chat. Okay. Yeah, so please folks, please do not need to spam. I'm reading everything that is coming up. Okay, and I will be there till the end until all your questions are answered, but do not please spam the chat. Okay, but please be extremely active. I'm using cursor as my ID. Okay. I'm using cursor as my ID. It is a fork of VS Code actually. VS Code is I think most of you have actually used it. Cool. Moving on to the next agent that we have, it is going to be a DevOps agent. Okay, what it will do. I have a set of dummy logs over here. So whenever you folks program, or if you have deployed things to production and so on, there are a lot of logs which come up. And when something goes wrong, it is first of all a little hard to parse through those logs, because sometimes even like when I used to, before Adobe, I was in a startup, and I used to maintain production code over there as well. The biggest issue I had over there was that the logs were too long. They're very descriptive, very good in nature. But if something has went wrong, it's not like I'll just find it in the last 10 lines of code. Last 10 lines of the log. I will have to literally dig into what exactly went wrong. And it would take a lot of manual time for me to figure out exactly what was wrong. For example, I have taken like smaller logs over here so that you can actually go through this. Okay, let's say this is an example for dummy log where there was some database connection error. There are some database retries were there. It was trying to, my code was trying to connect to some database, but I felt some errors. There's some critical issues as well. Then there's an issue, let's say that you're deploying in Kubernetes, and again, some issues with the pod deployment. It was unable to pull some Docker image and so on. This is like 15-20 lines, but ideally in realistic scenarios, you will have like thousands of lines of logs. In that case, manually reviewing exactly what went wrong and all, and being able to fix that or revert whatever commit you did before that becomes a very time consuming. And these are very critical situations which you need to handle very fast. Okay, so we are going to build a DevOps engineer agent. The DevOps engineer agent will have 3 different agents running together, one after the other. We will have a log analyzer, issue investigator, and solution. And finally, a solution specialist. Okay, so log analyzer, issue investigator, and solution specialist. So this is what it will look like. I will explain it to you. And folks, are these diagrams in the whiteboard being helpful for you all? Just type in helpful in the chat. Are these diagrams being helpful for you all? Yeah. Okay, cool. We'll continue that way only. Okay. So this agent that we're going to build now, the second one is going to be a DevOps let me just do this. Yeah. Engineering agent. Okay. What would it look like? Initially, we will have a set of logs. Okay. So this is nothing but a log file like what I showed you. Okay. So this log file is going to look something like this. Whatever logs are there, this one and this one, either one doesn't matter. So there will be a log file. This log file will go through our agentic system. We'll go through our agentic system and tell us what are the things that we need to do. The first agent that we will have in this case, agent 1, is going to be called as log analyzer. We are not requiring any tool in this. This will just be an LLM, which will, what it will basically do, it will just take this piece of text. This will actually one tool will be required over here to read the files. Read. Yeah. So what this agent number 1 is going to do, it will take this txt file, log file, whatever kind of file that you have. Okay. It will read that file. It will use a tool to read that file. As I said, LLMs cannot read files on their own. They cannot read PDFs or whatever type of file that you're uploading. There has to be a tool which is actually helping them read those files. It will use this tool to read the file and let the LLM of the agent know that, hey, I believe this is what mainly the logs are looking like, and you can analyze this, figure out what are critical issues and so on. Once this is done, once it has figured out here that these are the issues, agent 2 comes into the picture. Agent 2 comes into the picture. Okay, so if I open up the agents, log analyzer is done, then we will have agent 2, which is the issue investigator. So I'm calling it the issue investigator. It will have access to a tool which can allow it to search the web or do web search for us, just like we humans do it. About it's a way of talking we humans do it, as if we are like living in a world of robots. But yeah, so agent number 1 will be telling us that, hey Shan, this is a log file and I believe these are the critical issues and these are possible actual set of problems. Okay, actual set of problems that are there that we need to solve for. Okay, that we need to solve for. All of this context will be passed on to agent number 2. Agent number 2 will have access to web search. So whatever issues are there, whatever errors have been faced in the logs, it will search the internet for all of that. Okay, it will search the internet for all of that and figure out solutions to that, general solutions to this problem which people have come across. Once we are done with that, we will have our final solution specialist agent. Okay, we will have our agent number 3, which is called as a solution specialist. The tool, it doesn't require a tool actually, but there is one very important thing which is it is doing, solution specialist. Okay, this solution specialist not only takes inputs from the issue investigator, it will also take inputs from agent 1. Okay, what are these inputs? First of all, it tells us, agent 1 tells that, hey, this is the problem. Agent 2 is telling it, hey, these are the probable solutions based on our case. Okay, now the solution specialist will review the problem exactly figured out by agent 1, review the possible set of solutions. This is not the exact solution. This is just like if I give you an error statement right now, you will just go on Google and search for, hey, these are the probable solutions that are there. But agent 1 will have the required context to solve that problem. Both of this, the problem, exact problem, and the set of solutions which might or might not be able to solve this problem are given to agent number 3. And it is agent 3's actual responsibility to figure out a correct solution for this problem. Response, which is going to be solution on how to solve this particular problem. What are the set of let's say resources you figured out which are best in terms of solving this problem. Okay, so reviewing it again, we will have a log file which looks something like this. You can have any log file, you can just dump it from whichever instance and all you are using. That log file goes to a log analyzer, which will figure it will have a file read tool. So you can't, it is a .log file. You can have a .txt file, you can have any form of file, you can have a .pdf or anything that you have over there. But the LLM can't read that. So we give it a reading tool, file reading tool. It will just take this text and put it to the LLM. Okay, this will figure out what are the actual problems. Okay, so these problems will be communicated to agent 2 and 3, both of them. Agent 2 is the issue investigator based on the problems that have been communicated by agent 1. It will go on the web. It has access to a web search tool. It will go on the web and it will figure out possible set of solutions that might solve this problem. It can go through GitHub, it can go through Stack Overflow, it can go through these articles and all. And finally, agent number of 3 will take in inputs from agent 1 that, hey, this is the exact problem. It will take inputs from agent 2 that this is the set of solutions, and it will finally be able to figure out. It does not need a tool for that. The LLM itself can do it. Finally able to figure out that, hey, this is the exact solution that you should be using for this particular problem. Okay. Do you know how easy it is actually for me to convert it to code? You can you can try it like in any of these things as well. This is not like a part where we do it, but for me to be able to convert this to code, I can just take a screenshot of this, put it on cursor, and I can ask it to refer to the crew AI documentation. I have it indexed and generate the required agents, tasks, and crew to perform this task of a DevOps analyzer. Refer to the logs in the dummy logs folder. That is it. I just do it this much. Okay, I actually just do it this much, and cursor will actually generate the entire example for me. Yeah, this is just something extra, not what we are going to do today. But so I see a couple of questions. I'm just going over them one. Yeah, a couple of things where people might be stuck in. I'm taking these questions only because I feel a bunch of different people might be still feeling it. First of all, you might think that, hey, Shan, the logs are really larger in case, how will you actually feed everything? You don't need to. You can have a RAG-based system on top of it, which can feed it. So you can't basically feed thousands of lines of code. Instead of agents, can we just have prompts or LLMs? These LLMs, you will still have to give it, you will have to write your own tools in that case to access the text in this file. And you will have to write a tool which can access the web. The LLM cannot access the web for you. That is why we are using an agent over here. Okay. Bundle crash logs. Yeah, Ashish has a very good point. Can we add like one more step where we have context of any of the previous crashes and all? That is where memory comes into the picture. So in my memory, we will have a lot of the previous logs as well. Okay, and if anything breaks in the flow, that's like a totally different thing. We will take all of that towards the end. Cool. Moving on, let's look towards the code for this. Okay. First of all, we will start with defining our agents. Now, in the beginner set, how did we define the agents? Just imported it from crew AI, defined my LLM, defined a couple of parameters in the agent. We are going to increase the number of parameters that we are defining in this case. Okay, so we will see a couple of new parameters, and I will explain all of that to you as well. So don't worry about it. Again, same pattern over here. To define an agent, I have created an agents.py file. And you don't need to name it agents.py or main.py or task.py, anything of that sort. You can just name it whatever you want. But it is just a cleaner way to code. You can just define all your agents in a file, define all your tasks, tools, and everything in a file. You can have it in a Colab notebook, you can have it in a Jupyter notebook, wherever you want. Okay. So from CrewAI, I have imported agent. From CrewAI.llm, I have imported LLM. And in LLM, again, I have defined the same model, the GPT-4o. I'm using the OpenAI Router API key. Temperature I've set to a lot lesser now. Tokens and timeout is basically about 2 minutes. Okay, this is pretty much very similar to what we had already defined. Just reduce the temperature because I don't need the model to be creative over here. It has to be very definite and very to the point, and not exactly to the point, but there's no creativity required over here. You just have to figure out what is the issue in the log. So I've set it to low. If I would have been creating an agent as a script writer or story generator, I would have probably set it to about a 0.8 or 0.9 or something. Okay. Secondly, all three of these agents, you can think of it in this way. All three of these agents, log analyzer, issue investigator, solution specialist, are specializing in one particular task. But at the end of the day, they are all a part of a DevOps engineering agent. Okay. Am I audible? Oops.
Yes.
Am I audible, right?
Yes, yes.
Yeah, cool. So, yeah, cool. Got it. So look at it this carefully, and it's extremely important to understand that these three agents, log analyzer, issue investigator, as well as solution specialist, although these are three separate agents and have their own specialized tasks, but at the end of the day, they are a part of a larger ecosystem, which is for a DevOps engineering agent. Okay. So do you think there will be some things which are common between these three agents in terms of prompts, and some things which will be making them specialists? Okay, just type in yes in the chat. Like, let's say as an engineering team, okay, for example, as an engineering team, there are some principles which are common to everyone, all of you. There are some coding standards which are common for regardless of you are a front-end engineer, you are a back-end engineer, anything that you are. Okay, regardless of all of that, whatever you are actually doing, we'll have a set of common things in terms of system prompt. Okay, that is what we call as a system prompt. I'm not talking in terms of parameters, but I'm talking in terms of the prompt. Okay, so let's say in this case, I have a system. I have defined a system template for DevOps. This will be passed to all of my agents. This will be passed to all of my agents. Let us go through this in carefully. And folks, writing the correct prompt, writing the very accurate prompts is extremely important. It can be the maker or breaker of your agentic systems. So you have to be very careful on how you are writing it, what you are writing, and so on. Like in this case, I have written it very clearly in bulleted points as well as in numbered lists and so on. Okay. So in this case, I have written that you are an expert DevOps engineer with extensive experience in experience in infrastructure automation and orchestration, container technologies, Docker, Kubernetes, CI/CD pipelines, monitoring, logging, observability, cloud platforms, security best practices and compliance. Always provide. So all of these three agents are always supposed to provide a detailed technical analysis, step-by-step solutions, best practices and recommendations, any risk assessments, and references to official documents only. So because we have agents which are referring to solutions and issue investigations, web search and all, I want you to not refer to some random articles on the internet, but refer to original documentations and focus on practical production ready solutions. Don't give me solutions like restart the system. Okay. So this template will be passed on to all of them. Okay, so there is a parameter which is called a system template, and the same parameter has been populated to all of my agents. Okay, to all of my agents. Now, folks, there are a lot of parameters. Don't worry, I will explain all of them to you. Some of them are common, like role, goal, LLM, and backstory. In terms of tools, we have another extra parameter over here. Verbosity is there. We have max iterations. We have max requests per minute, and we have max execution time. Okay, what are these parameters? These are extremely important and very crucial in building such agentic applications. Okay, I'll quickly take you through what are these parameters. Okay, and these are very important. So please keep in mind. Okay, so we have three parameters which we are going to talk about over here. Okay, the first one is going to be let's say max iterations. Second one is going to be this one, max execution time. Max execution time. And third one is going to be max RPM or max requests per minute. What do all of these mean? Max iter stands for maximum number of iterations. Okay, what does maximum number of iterations mean? If I give you a problem to solve today, okay, let's say your manager comes and he gives you that, hey, Ishan, there is this one particular problem which you have to solve. Do you think, and not only extremely easy problems, intermediate, moderately complex problems, do you think you can just attempt it in the first go and solve every problem that you get in your life? Again, like, I'm talking about life, but in terms of code, let's talk about code. Do you think at just the first go, there are chances where you will be, okay, but most of the cases you will have to reiterate a lot of times. So you came up with a solution, you discuss it with a couple of people in your engineering team, you discuss it with your manager, and so on, and you get some feedback. Based on that, you improve on top of it, and so on and so forth. So you run through multiple number of iterations for that. Similarly, when an agent is actually doing something and you have given it a problem to solve, do you think it can go through thousands of lines of code and just give you an analysis that, hey, these are the 5 set of problems just by iterating it through once? It cannot. It will have to go through it multiple number of times. And yes, the code will be given to all of you. Please don't worry about that. Okay. So it will have a very hard time, right? If I give you 1,000, just think of it for a second. If I give you 1,000 lines of logs and ask you that, hey, you can just read the log